So, okay, hi. Yeah, so last time we were doing triple integrals, right? We started looking at triple integrals. And I said today, mostly we're just gonna do group work, but let me just remind you of what we were doing. Remember the idea was you have a region in space bounded by some surfaces. And I think all the examples I have, you wanna project onto the XY plane, or you can do them all projecting on the XY plane. So what you wanna do is you identify, there's always, like in these examples, there's always two Z equations. Like you can solve for Z two different ways. And that's gonna be like the top surface and the bottom surface. And then the shadow, I'll write some of this on the board in a second, but just remind you. So the shadow, you look for the shadow, so you have the top and the bottom surface, you have to identify those. But you do that after you find the shadow, right? And you find the shadow by intersecting the two Z equations and looking at vertical walls. Does that sound familiar from Monday? Let me write some of that on the board. Because basically we're just gonna try this starting from like number 3. Starting from number 3 on the handout. So triple integrals, the process for setting them up. So region, we have a region W in space determined by some surfaces, right? Bounded by some surfaces. And the surfaces are given in equations in X, Y, and Z, right? These are equations given, I guess I should say given by equations in X, Y, Z. So to find the volume, integral over W dV, or a triple integral. We haven't really talked about these, but I could also stick a function inside here. I could stick some function of 3 variables in there. The process is as follows, right? We said, if you want to project onto the XY plane, basically, if you want to look at the shadow in the XY plane, well, okay, let me just write the sort of the general thing. So W, I'll even leave the function inside here for a second. That's the integral over the shadow R in the XY plane. That's really a double integral of the integral Z equals the bottom surface to Z equals the top surface F dz dA. Right, that's what we sort of said. We do this if the shadow in the XY plane is sort of nice, right? So if like, basically here, if there's two, you look for two Z's in the list of surfaces. So like in this example, there was a Z here, Z equals X squared, and a Z there from Y plus Z equals 10, right? The example number 1 from the handout. And so you have to identify the shadow by 1, intersecting Z equations, and 2, looking at the vertical walls, which are the equations not involving Z. not involving Z. Right, and then you identify the top and bottom by, once you have the shadow, picking a point in the shadow and plugging it into both equations and seeing just which one's higher, right? Which one's bigger. This is kind of the process we were doing on Monday, so hopefully it's, I mean, you probably have a lot of this in your notes already, but we ID top and bottom, pick a point in the shadow, plug into each Z, see which is larger, which is smaller. Each Z in terms of, each Z equation, and see which is bigger and smaller. Because the bigger will be the top surface, right? And the smaller will be the bottom surface. Okay. Does that make sense? That's like the process. And then you start to set up the double integral over the shadow just as you would a normal double integral. Maybe I should write that too. Then set up double integral over the shadow as we normally do. And then you end up getting a triple integral, right? You end up getting 3 iterated integrals. Okay. You can see how we did this example. We did this example out last time. This example 1 from the handout. So really all I want us to do is, and you can pull the handout up if you want to see the process, the steps. But I really just want us to do the same thing for, we did number 2 also at the end of class last time. This one we intersected. There were no equations not involving Z. So there were no sort of quote unquote vertical, what I called vertical walls. We just intersected these two to find the shadow in the XY plane. But I think you can do the same thing with each of these. There are cases where you do want to find the shadow in the XZ or the YZ plane instead. It might be easier. Like number 4, you can do it. You can still project on the XY plane if you want, but you have to solve this Z for 2 different, 2 different equations. But you could also project into like the XZ plane or something if you wanted to. So basically I'm saying do 3, 4, 5, and 6, and hey, if you finish those, set up every integral in all 6 possible ways. Because we talked about that last time too, right? You can project onto any of the 3 coordinate planes, a shadow in any of the 3 coordinate planes, and then set up each double integral in 2 ways with horizontal or vertical slices. So there's really 6 possible ways to do this, right? Makes sense? Should we just jump into group work and do it? Start with number 3. Let's do it. Go find groups. I guess you can kind of stay at the same groups you were using last week if you want, or just break yourselves up into groups. I'll let you guys figure it out. Let's start with number 3. Those of you on the Zoom, you can maybe put stuff in the chat. Try to work on it. I'll try to put some of the answers on the board later in the class as we go. So, and I'll try to make sure to leave those. I'm gonna pause the recording now. Hey everyone, so just for the last 5 minutes, you guys are doing great. I've seen a lot of good answers to these problems. I do want to mention that, like, if you look at number 3, and right, number 3, this was the thing, right? This was the kind of shape that it is. Again, you don't have to be able to visualize this, but this was the shape from number 3. If you project on, if you take the shadow on the XY plane, it is this circle. You can sort of see the circle looking at it this way, right? You could project, this has a decent enough shadow also. So what is that, the YZ plane? But if you try to project into like the XZ plane, you get something kind of bad, right? Because it's like different. It's like different surfaces. It doesn't have a nice shadow. It's like you get this circle or whatever, but then you also get this little hump down here. And how can you tell that from the equations? Well, if we look at number 3 for a second, there's 2 Z equations, right? Which is why projecting on the XY plane was nice. There's also 2 X equations because this is doubled, right? Because you could solve that for X. There's 2 X equations. If you solve for X, you'd have X is like Z minus negative square root Z minus Y squared or positive square root Z minus Y squared. And so, right, solving for X is the same as projecting onto the YZ plane. So that's why you get this sort of nice projection. But if you try to project onto the XZ plane, or take the shadow in the XZ plane, there are really 3 Y equations because you'd have Y as Z minus 2, but you'd also have Y as like negative the square root of Z minus X squared and positive Z root Z minus X squared. So there's like 3 actually surfaces, a top for top and bottom, right? There's like a top, this top surface, and then this top surface, the little hump. And I guess underneath there's only 1 surface. So this would be really hard to set up. You'd have to use 2 triple integrals and it would be unpleasant. So you can sort of see in the equations, right? Like the shadow from this side's not as bad because there's only 1 surface, but it's the shadow from the other side that's bad. Does that make sense what I'm saying? Okay, but then the other ones, like for number 4, you can sort of project any way. If you project, like we said, if we project XY, you get this rectangle. Let's see, I'm trying to make XY. I think that's X and Y. Yeah, you get this rectangular shadow. But if you project YZ, you get this nice circle. I mean, that makes sense also, right? You could project onto the YZ plane. And then what's left? The XZ plane. I guess that's just a rectangle from a different, or no, this is the XZ plane, sorry. The YZ plane. I'm always trying to figure out how to make these work. Wait, that's Y and that's X. How do I do this? Oh, that's kind of it. Yeah, YZ plane. It's just a different rectangle, but it's also a rectangle. So it's sort of just interesting to try to figure out like what the right thing to do in each case is. But like I said, if you have just 2, like for example, in number 5, I think there's 2 Z's, so you can project on the XY plane. There's 2 X's, so you can project onto the YZ plane. And there's 2 Y's if you solve this, so you can project onto the XZ plane. So you could do it all 6 different ways if you want. Okay, so yeah. So it's just kind of a fun thing, but it seems like you guys were all doing well as groups. So, all right, let's wrap it up. We're out of time. So please straighten the chairs and erase the boards. But thank you, everyone. Thank you, remote people. Sorry that wasn't ideal for you, but hopefully you were able to solve some of them.